Warning! Danger! These are the signs you'll see on warning labels. Warning labels appear on tools and products that you use when welding. They're there to, as you may have guessed, warn you. These days, it seems everything has a warning label, from car seats to microwaves to a roll of toilet paper. But that doesn't mean you shouldn't read them. Warning labels on your welding equipment and products contain important information you need to know. Please read them carefully. There are 3 main sections. Number 1, the signal word. Do you know what that is? Warning is a level 2 signal word, while danger is a level 3 signal word. Where's level 1, you ask? Level 1 should be your default level of caution, your baseline alert status whenever you are welding or preparing to weld. David, could you please move to the side? You're blocking the screen. Thank you. Where was I? Signal words. Okay, after that. Section 2, Statement of Hazard. This lists the specific dangers to the product or tool you're using. Number 3, Hazard Avoidance Instructions. This is where you'll see the safety precautions you should take to avoid the specific hazards. Read the labels. They might also contain references to additional safety regulations from OSHA, or the appropriate governing body for workplace safety in your country, and industry safety standards, notes about specific compounds in the welding fume which require additional ventilation, and where to go to get more information about the product. David, always practice caution so you don't have to be warned about dangers. And don't step in front of the screen. If you ever have a question about a product or tool you're using, go to lincolnelectric.com to find out the latest. Let's talk about how to read an SDS. SDS stands for Safety Data Sheet. It used to be called an MSDS for Material Safety Data Sheet, but we dropped the M to make it leaner and more hip. The new SDS is a 16-section document that is sent electronically to a customer and can also be found at lincolnelectric.com. Inside all Lincoln Electric consumable welding products, there is a safe use guide, which gives you information on where to find the SDS for a particular product. You can also use the QR code on the package. Okay, David, can you please move away from the screen? You know what? It's okay. We'll just go full screen to the shots of the SDS. Section 1 has the name of the manufacturer, the product type, and the name and identification number for the product. Pretty straightforward. Section 2, Hazard Identification, provides an overview of the hazards associated with the particular product. David, how are you even doing that? Why don't you look at an actual SDS? There are some on the table. Section 3 is a breakdown of the hazardous ingredients in percentage by weight in the unused product. I'm talking about this section here, David. Don't worry, most of this information is for use by your industrial hygienist. Section 4 is basic first aid info. Section 5 covers firefighting measures. Oh no. We have to keep moving while you're doing whatever it is you're doing. Section 6, spill control measures. Section 7 is handling and storage. Those are pretty self-explanatory. Oh, good idea, David. Section 8 is one of the largest and most important sections of the SDS. The first part lists exposure limits set by regulatory entities like OSHA and recognized health science organizations, with specific references listed by country, state, and province. Okay, that's fine as long as you guys stay seated so we can see. The second part of Section 8 lists exposure limits for chemical byproducts produced during use or decomposition, biological exposure indices, as well as additional information regarding exposure guidelines, engineering controls, and personal protection. This section lists the basic material properties such as pH, flammability, etc. The next 2 sections, stability and reactivity, and toxicological information, contain information about the chemical and physical hazards. George, can you sit up front with David and Francis? Pardon me. These sections detail the variables affecting exposure potential, as well as potential effects of acute or long-term overexposure, including potential carcinogenic and reproductive effects. This information can be a useful reference for industrial hygienists, safety personnel, and/or occupational health professionals. Section 12 covers environment effects. 13 is about proper disposal. Ted, could you please sit down? Section 14 tells you how to safely and legally transport the material. 15 is important legal mumbo jumbo, and 16 is additional information, usually information about hazards that are present only when welding with the particular product. A Lincoln Electric SDS will also contain Lincoln's maximum fume exposure guideline. Everyone, please! Shh. Hopefully you've all learned how to read an SDS. Good evening, David. The following are some guidelines you'll need when working with engine-driven equipment. Number 1, fuel. I'm talking about gasoline, diesel, kerosene, propane. Fuel burns. That's how it works. So be careful. Keep your fuel away from fire or sparks. Turn off the engine before refueling. Don't smoke when refueling. And for heaven's sake, don't spill. If you spill, clean up in a manner that would make your mother proud. The rag you've used is now a hazardous material because it's soaked in gasoline or whatever fuel you're using. Throw the rag away the right way. Give the fumes a chance to disperse after you've fueled before you start up the engine or begin welding again. Gas fumes can explode too. Keep your welding arc away from fuel. Be sure and follow guidelines for proper fuel disposal. Shut off the fuel line before moving your equipment. This reduces the risk of a fuel leak. David, you don't think you need to shut off the fuel line? Do you want to end up like those stick figure guys, blown to bits? It's so easy to shut off the fuel line. Why wouldn't you do it? There's no sense in not taking a precaution that could save you or anyone else from injury or even death, is there? Don't be careless or lazy. It's simply not worth it. Engine exhaust sometimes contains small sparks. Most of the time, these sparks are not dangerous because they cool very quickly. But in certain circumstances, you may be required to install a spark arrestor. A spark arrestor is a small device that attaches to an exhaust pipe to trap these sparks. For example, when working in dry forested areas, on offshore oil rigs, and refineries, spark arrestors are usually required. Become familiar with the regulations associated with your work environment and install a spark arrestor if you need one. Most electrical equipment, including an arc welder, contains switches, relays, and brushes which create very small sparks when operating. There is generally no danger with these sparks unless you are working in an area where explosive gas may be present or can escape, and you shouldn't be welding under these circumstances. Your welder has moving parts inside, most notably the cooling fan. This equipment is enclosed for your protection, so be careful when opening these enclosures. Lastly, always read the manual. That's what it's for. Someone worked very hard on that, and their work deserves to be put to good use. There's no sense in trying to figure something out on your own when the instructions are available to you. Good night, David. David, it is common to work with portable power generators, and OSHA, or your local safety regulatory agency, requires additional protection from electric shocks when you're using portable generators. This is where GFCI comes in. David, what are you doing? GFCI is short for Ground Fault Circuit Interrupter. These monitor power cables for leakage to ground and will shut off power to the circuit if even the smallest leak is detected. They're more sensitive than circuit breakers or fuses. Remember, a shock of 120 volts can kill in certain circumstances, so it's important to follow the regulations regarding when GFCIs should be used. David, what does this have to do with GFCI? It's important to know the limitations of GFCIs. If a hot lead is leaking current to ground, an electric shock hazard may exist unless the power is shut off. And they do not prevent shocks if you receive the shock from touching two hot leads. They also don't prevent shocks from the welding circuit. But GFCI is not a free pass. You must still use all the safety precautions we discussed in the electric shock module. David, what the... I'm just going to keep going, is that okay? GFCIs are required on most outdoor and construction sites, and if you are using your own welder, you may be required to have the GFCI installed on your unit. Safety inspectors are out there, so be warned. Breathe in. Relax. Feel the earth beneath you. We're going to talk about grounding. What's that? Oh, I see, right. Yeah, that makes sense. Sorry, David, looks like we were talking about electrical grounding. Why don't you grab a seat? Electricity always finds the shortest, easiest path to ground, unlike David, whose head is always in the clouds. Under the right circumstances, David could be part of an electric current's path to the ground and receive an electric shock. We're going to talk about 3 kinds of grounding: earth ground, chassis ground, sometimes called frame ground, and welding ground, also known as work cable. Standing on a metal chair is not going to help you, David. But don't worry, nothing is going to happen to you. I promise. You can get down. This is the symbol indicating an earth ground. It's also usually indicated by a green wire or green screw inside your equipment. This symbol indicates a chassis ground. A chassis ground is a grounding to the frame or chassis of a piece of equipment, but the chassis must in turn be connected to an earth ground on another piece of equipment. Think of the chassis ground as an extension cord connecting your circuit to the earth ground. A welding ground is also called a work cable. It is connected from your welder to your workpiece, necessary to create a complete circuit in which the welding current flows. It is impossible to strike an arc on a piece of metal unless the work cable is connected. If you need more information, get a copy of the National Electrical Code and look up the article on grounding. This can be found at your local library or in most bookstores. I see by the green wire, David, that you are grounded. This is very good for meditating, but keep in mind, when welding, you want to insulate yourself from ground to prevent yourself from being a potential path for electricity to reach ground. Namaste, David. David, it's time we had a talk about carbon monoxide. Carbon monoxide is a byproduct of fuel burning. It can come from natural gas, propane, or gasoline. It's emitted by any engine-driven equipment you use. It can also come from the arc welding process. We are exposed to non-lethal levels of carbon monoxide every day. But outdoors, where it can dissipate, it's not directly harmful to us. In enclosed or poorly ventilated spaces, however, carbon monoxide can be deadly. It's why you don't run your car with the garage door closed. What makes carbon monoxide especially dangerous is that it's colorless and odorless. David, you could be sitting in a cloud of carbon monoxide right now. The initial symptoms of carbon monoxide poisoning are similar to the flu: headache, fatigue, shortness of breath, nausea, and dizziness. Relax, David. You are not in a cloud of carbon monoxide. You are perfectly safe. And we know this because we've installed a carbon monoxide detector. It's a good idea to install carbon monoxide detectors in your workshop or any space where you're working, and if your work area is not properly ventilated, harmful concentrations could build up. High-level CO poisoning results in progressively more severe symptoms, including confusion, vomiting, loss of coordination, loss of consciousness, and eventually death. Preventing CO poisoning is simple. Be aware of when it may be present and only operate engine-driven equipment outdoors. If you start noticing the symptoms, shut off the source of carbon monoxide if possible, leave the space immediately, and let your coworkers know. And don't return until the CO levels have been tested by a professional. David, remember your carbon monoxide detector? You're fine. Many welders are mounted on a trailer to be easily moved to a work site. Trailers are generally very durable and reliable as long as they are installed properly and regularly maintained. Oh, for heaven's sake, David! Make sure the weight of the welder you'll be towing does not exceed the trailer's capacity. Don't overload your trailer. David, come on. When mounting your welder to a trailer, check your trailer's specs and make sure you have the proper tongue weight. David! I'm not even dealing with you. Can we cut to an animation here? If your welder is mounted too far back, your trailer may sway while towing. If it's mounted too far forward, you may exceed the capacity of the tow hitch or coupler on your vehicle. Make sure you're towing the trailer in a level position. Attach your hitch or coupler in the proper way. Inspect and secure your trailer jack and any other equipment on your trailer, and use chains when going above 10 miles per hour. Inspect your tires for damage and proper air pressure. Make sure you don't exceed load capacity for the tires. Inspect your wheels, bearings, and lug nuts. Shut off the fuel line on your engine-driven welder before towing to prevent leakage. Connect your trailer lights and test them to make sure they're working. Adjust your mirrors. Tow at a reasonable speed. If the trailer is not stable or something feels off, pull over and check your trailer and hookups. There's no reason to take chances with your equipment or safety. If you're going to be welding in a confined space, remember that hazards associated with normal welding are multiplied, so special precautions need to be taken. In the US, OSHA defines an enclosed space under the following 3 criteria. 1. The space is large enough that an employee can enter and perform assigned work. 2. The space has limited or restricted means for entry or exit. And 3. The space is not designed for continuous human occupancy. Fumes accumulate more quickly in enclosed spaces, increasing the risk of harmful exposure, explosions, or potentially displacing breathable air. A metal enclosure can be very dangerous as it can become electrically charged. An insulating mat and other precautions should be used. Employers must provide training and supervision for work in confined spaces. Always make sure that spaces have been tested for safe oxygen levels and toxic gases before entering, and make sure you have the proper training. You should check out your employer's confined space procedures and local regulations. In the US, the OSHA document 20 CFR 1910.146. Can you remember that, David? Okay, I'll write it down for you. Let's go over some basics of how to keep your work area as safe as possible. It's basically like being a good roommate. George will be playing your roommate, David. First, maintain the guarding that comes with any machine or hand tool you use as it was originally intended by the manufacturer. If you want to express yourself, consider a tattoo. Leave your tools and equipment the way they came. Put your tools away after each use so they don't get in the way. Keep your work area clean and free of debris. This will minimize trip hazards and fire hazards, as well as just making a generally nicer place to work. Don't you think? Working at heights? Wear the proper harness and take necessary precautions. Look out below! Not just for people, but for combustible and flammable materials too. Sparks may fall farther than the usual 35-foot radius when working in an elevated area. Know where the emergency exits and evacuation routes are. Finally, understand your role in an emergency. David, it's not to push the panic button. Why do we even have that? Hey, David, want to hear some cool science? Electric current flowing through wires, equipment, and workpieces cause electromagnetic fields, or EMF. You can't see them or feel them, but they are there. Science does not yet know for sure if these fields are harmful, but it has been suggested that exposure to EMF from power lines, microwaves, and cell phones may have some negative health effects, including cancer. Though these claims have not been confirmed, it's a good idea to minimize EMF exposure while welding. Route your electrode and work cables together. Secure them with tape or tie wraps when possible. The EMFs are reduced wherever these cables are routed together. Never wrap cables around your body. That's just a bad idea for all sorts of reasons, EMF exposure being only one of them. Don't place your body in between the electrode and work cables. Make sure both cables are always on the same side of you. No sandwiching. Make your work cable connection as close to the point of work as possible. This minimizes the distance the current travels across the workpiece and therefore minimizes the EMF. Don't work directly next to the power source. The welder has its own EMF from the current inside the welder. No, David, those EMFs won't cook your dinner. Always weld at the lowest DC output setting acceptable for the particular job you're doing. This will minimize the EMF. One last thing. David, do you have a pacemaker or defibrillator? EMF fields can interfere with some pacemakers and defibrillators, so consult your doctor before welding if you have a pacemaker or defibrillator.